Hi everyone, we are finishing our unit on angles, so the first thing we're going to do is talk about some definitions before we get into our applications. So first thing is the difference between an angle of elevation and an angle of depression. Okay, so angle of elevation I think is a little bit more obvious, so you start with kind of your baseline. So we have a horizontal line here, and then our angle extending upwards is our angle of elevation. Right? Makes sense. So for instance, if something was taking off from the ground, that would be the angle from which it left the ground. Right? So that is going to be our angle of elevation. Cool. Right, now our angle of depression is basically the opposite. So now if we have some flat line, I guess it could be the ground, but most of the time it won't be. Some angle in which we are descending from that line, that is going to be our angle of depression. Okay. So I know that my horizontal lines here are going to be parallel, so by alternate interior angles, I know that angle 1 is going to be congruent to angle 2. Right, so my angle of elevation from one point is going to be congruent to the angle of depression from the other point. Alright, so from P to T, I know angles 1 and 2 will be congruent. Okay, let's just do a little bit of practice and talk about classifying each angle as elevation or depression. So looking at angle 1, I see that I'm starting from my flat line and then I am extending downwards. So 1 is going to be depression. 2, I have my flat line and I'm extending upwards. So that is going to be elevation. 3 is the exact opposite. I have a flat line and then I'm extending downwards. So that is going to be depression again. And then 4, I have my flat line and I am extending upwards. So this will be elevation once more. Right? Go ahead and give this one a shot. So pause the video and see if you can classify angles 5 and 6 as elevation or depression. Alright, so angle 5 is going to be an angle of depression. Angle 6 is going to be an angle of elevation. Okay, so 5 is extending downwards, 6 is extending upwards. That's essentially the difference here. Alright. So let's draw a picture for this and then just true or false. So first question, the angle of elevation from your eye to the top of a tree increases as you walk towards the tree. Alright, so let's think about this. Let's say we have a tree, pink tree, and let's say we're all the way over here. And here's my line of sight to the top of the tree. Okay, so this would be my angle of elevation. And now if we move closer to the tree, let's say our line of sight stays the same. Now if I compare my angle definitely has increased in size, so this would be true. Alright, let's go over here. So as we watch a plane fly above us, the angle of elevation to the plane gets closer to 0 as the plane approaches the point directly overhead. Okay. So here we are again. And let's say there's a plane. Okay, I'm not an artist. There's a plane, and let's say this is my line of sight to the plane. This is my line of sight to the horizon. Okay, so here is my angle. Now, if the plane approached directly overhead, supposedly my angle would be getting closer to 0. But really, since my line of sight is staying the same, it's approaching more of a right angle. So I'm going to say that this one's false. Okay. Now, if we're standing at street level, the angle of elevation to a building's 10th story window is greater than the angle of elevation to one of its 9th story windows. Okay, so we have a building. Let's say this is the 10th floor, this is the 9th floor. Alright, so I'm standing over here, and my line of sight is here. Right, so if I draw my line here, and let's use a different color, and I draw a line of sight from the 10th floor, what they're saying is the angle of elevation to the 10th story window is greater than the angle of elevation to the 9th story window. So I see that my blue angle is in fact greater than my pink angle, so this will also be true. Alright, last one. An angle of depression can never be more than 90 degrees. Okay, so all we have to do is explore. If I have a flat line, this would be considered my angle of depression. Okay, so if I go straight down, so I'm essentially just drawing a rays here. If I draw an angle straight down, that would be 90 degrees. Okay, now what happens if I go that way? Then would that still be considered an angle of depression? And is my angle obtuse? What we would say is, rather than thinking about this as an obtuse angle, I would consider the linear pair, and I would consider this acute angle to be my angle of depression. So this is, we'll say, in fact, true. An angle of depression would never be more than 90. We would just use the supplement. Yeah, we would use the supplement. Alright, moving on. So our next example, we have the Space Needle in Seattle casting a 67-meter shadow. So that's my bottom leg there. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70, so that's angle A, how tall is the Space Needle? So I'm solving for y. So what I need is a relationship between my angle A to the opposite and the adjacent. So if I remember from my handy-dandy acronym, opposite over adjacent is tangent. So I will use tangent of 70 degrees to be y over 67. That means y will be 67 tangent of 70, 67 times tangent of 70, I should say. Therefore, y is going to be 184 meters. Right, next example. We have a building located 400 feet from a wind farm turbine. A worker is standing at the window on the second floor of the building. The angle of elevation to the hub of the turbine is 35.5 degrees. The worker's eye level is 15 feet above the ground. So how tall is the turbine from the ground? So we have some guy. Okay, let's say that's our guy. He has a line of sight that is 15 feet above the ground. Okay, and furthermore, this dude is 400 feet from this turbine, which is gonna, I don't know, look like that kind of. Alright, so we want to know how tall the turbine is. So our angle of elevation to the top of the turbine is going to be 35.5 degrees. So what we need to do is solve for this value right here, right? So whatever I get to be this length, I will add 15 to it. So we'll call this x. So I have my adjacent, and again, I need my opposite. So I will use tangent of 35.5 to be opposite x over adjacent, which is 400. Right, that means that x will be 400 times tangent of 35.5 degrees, or 285 feet. Okay, now we have to add this extra 15, so that means that my total height is going to be 300 feet even. Alright, next example, I have an ice climber standing at the edge of a crevasse that is 115 feet wide. Okay, so here's my dude, and we are 115 feet. Okay, the angle of depression from the edge to the bottom is 52 degrees. Okay, so it's coming down. Here's my 52. Hey, how deep is the crevasse at this point? So I am looking for this value right here. So again, I have an opposite and an adjacent, so I will use tangent of 52 to be opposite over adjacent. That means x will be 115 times tangent of 52. Don't need that. Okay, so that means that x would be 147 feet. Alright, so go ahead and give this next example a shot and then check and see if you got what I got. Okay, so we have a ranger atop a 90-foot tower, sees a fire, the angle of depression is 3 degrees. So we have tower, there's our dude. Okay, so the angle of depression from, I guess we would say the tower, because we don't know how tall he is, so that would be very difficult, to the fire is 3 degrees. Okay, this is the fire. And I want to know the horizontal distance to this fire. Right, so we will call this x. Okay, I know that the tower is 90 feet, so that means, again, I need opposite over adjacent. So I know that tangent of 3 degrees is equal to 90 over x. That means that x will be 90 divided by tangent of 3, or 1,717 feet. Alright, last two examples. We have a lighthouse 69 feet above the water, and there are two boats directly in front. The angle of depression to the nearest boat is 48 degrees. The angle of depression to the other boat is 22 degrees. We want to know the distance between the two boats. Okay, so this is the first time we're dealing with two triangles in the same problem. It'll help if we draw a picture, so let's draw first our lighthouse. I'll draw it over here. We're going to run out of room, I think. So let's say this is what a lighthouse looks like, maybe. And I'm not totally sure. And what's happening is this is 69 feet tall. There's a boat here, and there's another boat further away. Okay, and what's happening is my angle of depression between my lighthouse and my boat is going to be 48 degrees. So I'll use a different color to show the horizontal here. So it would be really easy to accidentally use, I'll show you, to use this angle here as my angle of depression. Make sure that you do not do that. Your angle of depression is always with the horizontal. Right? So this angle right here would be 48 degrees. Okay. On top of that, we have another angle that is going to my other boat, okay, and that angle right here, so it's smaller, is going to be 22. Do that right here. So if you can picture, this angle here is 22 degrees, whereas my larger angle is 48. So this is kind of a complicated picture, so what I'm going to do is rewrite this as two triangles. Right, so let's do our closer boat first. Okay, so I have my lighthouse 69 feet above the water. And what I'm looking for is this distance down here, right, which represents this distance here. Okay, and I know that my angle of depression is 48, which we could find the complementary angle here, but I also know because of alternate interior angles that my angle down here is also 48. So the angle of elevation from the boat, we could say, is 48. Okay, now I have another triangle, which is longer, and 69 is constant. Again, I'm looking for my horizontal distance, and I know that this angle is 22 degrees, which means the angle of elevation from the boat is also 22 degrees. Okay, so that represents this. Now what I'm looking for is the distance between them. Okay, so what I really want is y minus x. Okay, that's what I'm really looking for. So to set that up, let's solve each of our triangles. So again, I have an opposite and I have an adjacent. So to solve for x, I can set up tangent of 48 is equal to 69 over x, which means that x is going to be 69 over tangent of 48. Alright, we'll just leave it like that for now. Now same thing with my blue triangle. I can set up tangent of 22 is equal to 69 over y, meaning y is going to be 69 over tangent of 22. Cool. Now I can plug these in to my equation here. So I know that y minus x is 69 over tangent of 22 minus 69 divided by tangent of 48. Right, so my final distance that I'm looking for is going to be 109 feet. Alright, next example is very similar to the one we just did, so what I'd like you to do is pause the video, use what we just did in example 6 to try to solve this problem as well. So go ahead and pause the video and give it a shot. Okay, so similar situation where we have a plane. Let's draw a plane here. Okay, so we have an airport we're almost directly above, and we have an airport very far off in the distance. Right? So I have a line of sight to each of these airports along with my original line of flight. And that's how I know my angle of depression. So my angle of depression to the blue is going to be 78 degrees. My line of depression to my pink is 19 degrees. It's much shallower, much further away. So what I'm going to do again is set up two triangles. Okay, so I have one triangle here. So if you can picture my triangle here, and I have another triangle in a very similar location here. And again, I'm looking for these horizontal distances to subtract them. So first triangle, I know that I'm 12,000 feet above the ground. I'm searching for this horizontal distance, and I know that my angle of depression is 78 degrees, meaning my angle of elevation from the airport will also be 78 degrees. So I can set up tangent. So tangent of 78 is going to be 12,000 divided by x, meaning x is 12,000 divided by tangent of 78. And my second triangle, I'm seeking my bottom leg. I know that I'm 12,000 feet above the ground, and I know my angle of elevation from the airport is 19 degrees. So tangent of 19 is going to be 12,000 divided by y. Y is going to be 12,000 divided by tangent of 19. And again, I'm seeking y minus x. So that's going to be 12,000 divided by tangent of 19 minus 12,000 divided by tangent of 78. Makes sense. Tangent of 19 is going to be a smaller number. We're dividing by a smaller number. We'll get a bigger number. So my final distance looks like it's going to be 32,300 feet. Alright, your homework is the worksheet below. Give that a shot. Let me know if you have any questions. Otherwise, have a fantastic rest of your day.